this is the time, guys, where we will talk about this Adafruit SPI SD card. I've been promised you to do a video about this module, been long time already, but yeah, I was busy with something else, then I was sick for quite a long time. And today is the time where we will talk about it. Okay, so what is this? Is a SD card module. SD card module, we use it to store the data, same like these guys here. These guys here, they are the EEPROM, but these guys, they are very limited in the size, and at the same time they got very limited life cycles. So we won't use this anymore. We will use the SD card. This SD card can last for a long time and also can support very big data. This one might go for few kilobit up to maybe maximum 1 megabit, but this SD card, this exact one is support 512 megabyte, and there's another module can go up to 2 gigabyte or even 4 gigabytes. Okay, so this module again is a 512 megabyte, is a FAT format, and it supports SPI communication with a microcontroller. The thing you need to keep in your mind, guys, this SD card not a regular SD card. It's not the regular SD card that you can use it with a card reader to plug it to your computer or to your phone or any other device. This one is pre-soldered SD card. So it means this one meant to be used only for the embedded system or to be connected to the MCU like PIC or Arduino here. I will use it with the Arduino Uno. So if you want to read the data from this SD card, we need to use an MCU to read the data, buffer it, then send it to the computer, maybe through the USB or the UART. So this guy here is a SD card, but not a regular SD card, the one that you can plug in your computer or in the SD card reader. And this module is a 3 and 5 volt tolerance, so we can use it with any system without any problem. If our system supports 3 volt or 5 volt, should be okay. And also, this guy here, it can handle all the wear leveling and ECC, which is the error correction code. And also it don't have to manually erase the block. You just write to it, read them, then it will just behave like any SD card. Like you read the data, then we can delete it or process on. So no need to erase the blocks, just like with other flash memory. So in this tutorial, we will learn how to implement a very simple data logger, where we will use this SD card to store our data. Later we will see which kind of data to be stored inside this SD card. I haven't made up my mind whether we will do a real data, maybe a temperature sensor or vibration, whatever, or maybe just a random data, just for the sake of prove the concept of storing data inside the SD card instead of EEPROM. Then we will learn how to read it back again from the SD card and also buffer it inside our MCU. Then we send it to the computer through the USB or the UART. Let me start first with the schematics of the SMT SD card module. So we can see from here, this is the main chipset. This is the main SD card chipset. The part number is XTSD something. I'm not remembering the full part number. I will try to find it for you guys and I overlay on the video if I don't forget it. By the way, this card, as I mentioned previously, this module is from Adafruit. Okay, so this is the SPI SD card Rev A. Any dates? Yes, is around 26 January 2021. Yeah, around that time. So yeah, this is the main SD card chipset. You can see here, this is the bypass capacitor for the main chipset, and then here we have the buffer, and here we have the regulator. It looks like it's a linear regulator, and this is the pin headers where we will connect it to the MCU, which is Arduino Uno in this tutorial. So from here we can see we have two inputs, whether it's if we can connect it using the VIN or 3.3 volts. So the VIN will be going through the 3.3 volt regulator, then it will go to the rest of the circuit. Otherwise, if you have pure 3.3 volt, then you can directly connect it to the 3.3 volt, where it will bypass the regulator and it will supply the rest of the circuits. And then you can see here the pin out of the SPI pin out of the chipset doesn't directly connect it to the pin header, but it will pass through the this buffer. But surprisingly, the MISO, I have noticed it doesn't go through the buffer, which is the master in slave out. I believe it's the output from the slave, which is the chipset or the SD card, all the way to the master, which is the MCU. So it's go directly without passing through the buffer. The rest of the signals like MOSI, clock, and the chip select will go through the buffer, then go to the chipsets. I believe because the direction of the data might be different. So that might be the reason why the signals pass through the buffer. And also we notice here the chip select signal, which is the SS, is being pulled up with a 10K resistor. So yeah, that's all what I can see in the schematic. Is very simple and straightforward. Regarding the wiring of this module to the MCU, you may follow this wiring diagram. It's very simple and straightforward, where we just need to connect the SPI pins, 3 SPI pins, 1 chipset, and the power. That's all. So first is the VIN. Again, since we are connecting to the 5 volts, so we better to connect to the VIN. Otherwise, if we use the 3.3 volt, we connect directly to the 3.3 volt. Again, VIN go to the 5 volt, ground to the ground. Then we have the clock go to pin 13. As we can see here, also I mentioned for you guys, if you can see the wiring, you can just follow these wordings here. So the clock from the breakout will go to pin number 13. MISO, which is master in, slave out, go to pin number 12. MOSI go to pin number 11. At the end, the chip select will go to pin number 10. Yep, that's all. Easy peasy. So now, after I have completed all the wiring following the schematics I showed you previously, so now before we dive in the coding, let me show you how to read the card info to make sure that our wiring is correct. Okay, so we need to use this library which is called SD. If it's happened that you don't have this library and you don't know how to download it, do let me know. I will make a video for you guys. If I'm not may already have a video on that anyway, do let me know. I will help you on that. I'll make a video for you how to download and install the libraries in your Arduino. Anyway, so this is the library we're going to use, and we're going to open the card info first. So this example will show you the card info that's been connected to the Arduino, which again, as we said previously, is just SD card that's been permanently connected to your MCU. Anyway, so this is the example, and yep, chipset we already connected pin number 10. So we just need to burn to the Arduino, and let's see the output. So yeah, we have Arduino pin number 11. Let's go. There we go. It's writing to the MCU. Should be done at any time. Here we go. So we open the serial, and here is the output. So you can see here SD card has been initialized, wiring is correct, good, we are good to go. SD card type is the SD2. This is the clusters, block by clusters 8, total blocks this, and if you see, as we said previously, is a FAT32. This is the type or the formatting of the SD card. Here's the SD card size, which is in kilobyte, in megabyte, and in gigabyte, which is about half giga, is 512 anyway. And here it is. There is no data being stored yet, so it's still new. No files being found inside the SD card. So yeah, we are good to go now. we can go and dive into our coding of how to create new directory, new files, and write into the files, and also how to read it back. Now, let's learn how to list down all the directories and the files that we stored in the SD card, or in the built-in, I can say, SD card. So we go to File, Examples, again to the SD card library that we installed previously. We go to the list files. Here we go. So this example will list down all the directories, file, folders that we stored previously in the SD card. So since I already did some testing in the SD card, so I expect to see something. So let's upload the code and see what is the output. Okay, so now open the serial, and here we go. So you can see how we have folder 1 and we have data.txt. So folder 1 is a directory, or is a folder by itself, and this one is a file, which is a txt file. So now I can make new directory. Let's say, where is it? Where is that to print? Okay, this is the function that will print a directory. This is the loop that we are not using it. Let me just close it. And this is our setup function. Okay, so this is all initialization. Here we go. So here, to make a new directory, it's very easy, straightforward. Just sd.make directory. Okay. So now let's say my directory is what to call it. Let's say d1. Okay, and let's upload. So now we should see d1 directory is being added to my SD card. There we go. So you can see here folder data, which is a folder file, and there's another folder. I can add another one. Let's say the maybe not D. Let's see, data 1, for example. Okay, and here it is, data 1. So now, in order to remove the directory, I just need to first take out this. So I need to have sd.move directory, rmdir. Then you put the path of the directory, which one you want to delete. For example, I want to delete d1. There it is. So now we have only folder data 1. D1 is gone. Now, if I want to add more subdirectories to the directory, for example, D1, this one, data 1, I want to add more inside it. So I want data 1, add sub 1. So this sub 1 folder will be added inside data 1. Yep, exactly. You see here, we have sub 1 inside data 1. And now if, let's say, I want to add a file inside this folder sub 1. So what I can do is, so first I need to declare my file. For example, I have another, already have root. Let's add another file, which is file, let's say text file. So now here, where is the one that they call yeah, so here I will have x file equal to sd.open. Now where I need to add the file is here. Then sorry, I need to add 3 double quotations. So yeah, then the name of the file, let's say log data 1.txt. Yep. So this I will add the text file. We should see it under the sub. Since we can see the file being created, maybe I can see the reason. Maybe we need to add the type of the opening, whether we want it to be read or write. So let's add file underscore write. Yep. And let's try again. I believe that's it. Yeah, exactly. Here we go. So you can see here LD1 text 0. This is the size of the file, which is 0. And the previous data is 40,000 something. So now, how to remove the directory? Again, we learned how to remove, but now how to remove the file. Okay, so to remove the file, we need to use remove, not the rmdir. Rmdir is for the directory. Now we can use remove. So I can sd dot remove. Now what I want to remove, let's say I want to remove, oh sorry, I want to remove this one, data. So I want to remove data.txt. So this one will remove this data here for me. Let's try it out. Need to add some colon, forgot about this. Open the serial monitor again, let's see, and cool, there we go. You see now the data gone already from my list, or from SD card list. So yes guys, so here is how we can navigate and also like make a new directory, delete directories, add files, delete files. So next we will learn how to open the files or access the file, add or write inside them, close them, then later also you can read them back again and send them to the UART or send them through the USB or whatever we can do this. Well, so now we have reached to the point where we will load the data into the file inside our SD card. So here I will use the same template from the previous one, which is the list sketch, and I will start to add my code. So here is the initialization being done. This is all same what we have done previously, which is again inside the list sketch. So yeah, now let's see. I want to see which kind of data I want to add on. So let's say I have my data line equal to, for example, I have temperature, let's say 12 Celsius, for example, humidity 22, and let's say speed to 20. But I don't want to keep it like this, because sometimes, for example, if let's say the humidity is not available, might the speed come first and the humidity come last, or the temperature might go to the last. So it depends on which data been available or been ready first to be stored into the data line. So what I'm planning to do is data line will be equal to, first I will add the sequence from 0 until the max. Then I will add, for example, temperature equal to 11. Then I will add like humidity equal to 22. Then I will have the speed, let's say 222 equal for sure. So this is how it will be my data line. So if let's say there is no humidity, only speed, so it's okay, we still can decode it based on the address of the data. Okay, if we use this method, so for example, if we don't have, let's say, we have, let's say, temperature, but we don't have humidity, we have only speed, let's say 250. So if we encode it later, so if we decode it later by passing the string following the special character, which is the comma, then we might thought this is the humidity. Then since there is no speed, we thought the speed is 0. Actually, this is the speed. But with this method, it will be much stronger and powerful, where we will look into the address of the data So we won't miss any data. So for example, in this case, let's say I will have, for example, sequence to, let's say, number 0. I have my temperature correct, 11. Again, no humidity, but I have speed equal to 140. So here we can't make any mistake. Why? Because the data got the address. So now I know this T representing temperature, which is 11, S speed, which is 140. So although there is no H or there's no humidity, so I won't assume it is 0 or assume it as any number because of this address now. So we solve this issue by using addresses. Now I assume I have 10 lines of data. So I will make a loop here. The integer I equal to 0, and my I will be less than 10, and the increment is by 1. Okay, cool. So my data line will be data line equal to, but let me declare my data line here as a string. So string data line equal empty string, and now my data line will be, first again I need to add my sequence, so it will be plus equal the sequence, which is I. So I, since I go from 0 to 10, so this is would be my sequence. Okay, and what else? I need to add comma separation. So plus comma. Yep, that's all. That's cool. Next, data line will be plus equal to the address of data address, which is this. So first I'll add the T equal to plus I will have the data itself, which is for here, for example, I assume I have the analog read from, let's say this is from pin number 1. Anywhere this is your data, you can bring it from anywhere you are working on. So yeah, and then I need to add my separator as well, which is comma space, and yep, that's it. So this one we need to like repeat it another more 2 times. So another one for the humidity, speed as well. This one I assume this from pin number 2, pin number 3, just for example anyway. You can put your in data later on. The last one, we don't need these separators because it's the last data anyway. The last, we don't need to add any separators. Now for testing, let's try to print. So I have serial dot print line. Okay, and I want to print my data line. But I can see an issue here, Do you know what the issue is? After we print it out and go again, it will keep add more to our data line. We need to clear it. So equal to clear. Yep, that should be it. So now let's upload it and see what is the output of our code so far. Here we go. We can see here sequence 0, we have temperature, humidity, and speed. Temperature, humidity, speed, and all this data is from 0 to 9. That's good. So since I finished with my data, let me comment this. So now I will create my data file. Let's see if I have data file. Yes, I have this data file. So this is the object where I will open the file into before I write to it. This file is in the SD card, by the way. So this guy will be equal to sd.open. what I want to open my data. So I have like, let me call it like log data, L data, .txt. And by the way, again, this one need to be in double quotation because this is address. And how I want to open it, I want to be file underscore write. Yes, I want to write to this file. So since I open it here, and by the way, when I use open, it will be create this file if it's not already existing. So now I can see if the data file is open, data file is correctly open, what I will do is, so data file dot print line, this one will keep printing lines inside the data file. But you need to send the data will be my data line. Okay, so this one will be stored inside the file. Then I assume I finish my first iteration of the first line, then I can close it. So data file close, please. Okay, or just to save the data when I just close one. Okay, it's very good practice to close the data whenever you open it. Otherwise, if you need it to open later, it might be like already opened by another object, which is not easy to access again. So it's better after you finish whatever you are doing, close it. Thank you. Then here I can say serial dot print line I can say data log. It's a Chinese New Year, by the way, guys, if you hear the noise and the firecrackers in the background. So yeah, everybody is celebrating and I'm here doing the tutorials for you guys. Anyway, so okay, so this is, so now, happy Chinese New Year, by the way, for all my friends and my followers. Else, if they say this guy is not happily open, got some issues, so I will have to serial print line. We got error while open the log data.txt. Yeah, that's it. And here I would prefer to add some delay because I don't want to be very fast, so I can see that the progress of keep appending the data set. 5 milliseconds should be enough. So I believe that's it. Let's check it out. Got issue. Close. Yeah, we forgot the E. Again, serial dot print. How come the compiler doesn't work? And whenever you add rubbish inside, it's still recognized as a reserved word. Weird. This IDE could be better. Whenever I add garbage to the reserved word, still being highlighted, recognized as a reserved word, so, or keyword. That's bad. The IntelliSense should be more sense than this. Okay, done. Let's see our data. So here we go. It's log. You see? Now let's keep logging. And here we go. So we can see this is our log data. Now I will restart. Let's see if this number will be increased. Here we go. Let's log in again. expects another, and here we go, become 600 something. Adding, now 800. That's good, that's cool. So now we know how to add our data. That's straightforward and easy. First we need to prepare or pre-process our data, how we want to store it, so later easy for us to process it after we store it. And then we open the file where we need or we want to write our data. Then we just use the print line, that's all, to print our data inside. Then remember to close it whenever you finish. And yeah, that's it. So let's go and see how to read back the data from our friend loaddata.txt. At this point, we have done storing our data. So now is the time to view our data and see what to do with it, whether we can send it to the Excel or store it into any other medias or whatever we can do. Anyway, let's try to read it first. So now let me comment this. So from our string, this serial, I believe that's all need to be commented out. So let's check if it's correct or we miss anything. Nice. So now what we want to do first, again, we need to access the file, or we open the file. So we can use this guy here. Here I access my file again. Now I'm inside the file. So what I will do, I will have while loop, while the data file is available. I just assume it as I'm receiving data from the what they call the UIArt. So while is available, so serial.println by printing what? Print the data file dot read. Okay, that's it. So after I print all our data, the one I read it from the file, again, don't forget to what? Close it. That's it. Let's upload and try again. See what is the response. There we go. Now you see, guys, what's the issue? That nothing being printed on the serial, because I open to write. I should just open it to read. I shouldn't add the file write. Now we should see our data. Here we go. Sorry, guys. Here shouldn't be print line, otherwise the data will be messed up. So it should be right. As long as we read, it will be right. So we shouldn't use print line, otherwise you see how messed up our data was. So the correct one is the serial write, the data that we read from the folder, or sorry, from the file. Again, so here's our data. So from 0 to 9, this is the first sequence or the first patch we stored it. Then again, we have 0 to 9. This is the second patch. This is the third patch. Here we go. So I believe we like keep storing the data for 3 times. So here's our data. So that's it. So this is the end of the tutorial. I mean, after this is up to you guys. This is your data that's been stored. You can either process it internally, or you can send it to the PC or to another system like Raspberry Pi. store it in the database, whatever. So the thing is, we can process the data by, I believe I have video on how to process the data or the string of data by parse them following the special characters. Then you take the address of the data to know exactly which data is this belong to. So yeah, I hope you have learned something. You have learned how to, so in this tutorial we have learned how to make new directory, delete directories, play with the files, like we prepare our data, then we store it inside the file, then how to access that file again and we read it again and print it on the serial monitor. But remember, when you print back to the serial monitor, don't use print line, use write instead. Thanks a lot. Happy New Year for the Chinese friends, and see you next.